Hello, chemistry students. Coming to you from Mrs. Turner's classroom today. She has her middle school students in our science classroom. So I'm in here. There's a lot of books and things are super orderly. I am a little uncomfortable, not gonna lie. But I want to continue on. I don't have a board to write on, so I'm just gonna kind of go through the main topics and how far I want to be you to be in the actual notes. I know we talked about alkali metals, alkaline earth metals, and transition metals. I do not think we talked about these yet, at least not in both sections of chemistry. So intertransition metals, we talked about transition metals, which is that center part of the periodic table. Let me go to transition metals. But we pulled those lanthanides and actinides and put them on the bottom. So we've yanked those out. Lanthanides and actinides are removed from the main periodic table. This is simply to make it a little more compact so that it's not this incredibly long, drawn out periodic table that would require an entire wall for me to hang it up. So we pull those out, but they definitely go into that intertransition metals group as their numbers would indicate. So just keep that in mind. Halogens. So halogens, group 17. So remember, these are the ones when we talked about diatomic elements. This group right here, group 17. These are the halogens. So fluorine, chlorine, bromine, iodine, astatine. And this whole row really, when we talk about diatomic elements, we usually include this whole group. Remember, sometimes I said, with some sources, depending upon what source you're looking at, some of them include astatine and some do not. So it's fine either way. But those are the halogens. Properties, I have to go back. Properties of halogens, so they are group 17. They are non-metals. They bond readily with metals. They love to bond with alkali metals or alkaline earth metals. Because they have an overall charge of -1, they bond readily to those alkali metals that have an overall charge in the ionic state of a +1. So yeah, those like to bond together. They have 7 valence electrons. Remember, everybody wants that stable octet, so they're either going to give up 7, which cannot happen. It gives it too much of a charge, one way. So it picks up 1 extra electron. It gains 1 extra negative charge, forming an ion of -1. And then the noble gases. They think they're better than everyone, the noble gases. They're not reactive. They were the last group of elements to be discovered because they're so non-reactive. Remember, we said Mendeleev was completely unaware of the noble gases. They have that stable octet, those 8 valence electrons already, so they really don't want to gain or lose any of their electrons. They don't want to pick any up. They don't want to get rid of any, so they are noble and not reactive. Okay, and when you did your periodic table coloring, you kind of talked about these periodic trends, so I just want to kind of go over them really quickly. One that I think is really interesting is atomic radius, because you would kind of think as you go across on the periodic table that you would see, oh, there's a person running right across my face. You would almost think that you should see, as the mass increases, that you should see the size of these atoms increasing as you go across. But it's actually the opposite. It's the complete and total opposite. I gotta move I should just not have my face on here, sorry. So if we look at atomic numbers, if we just are looking at atomic numbers, so this is the number of protons and also the number of electrons, right? That's what the atomic number tells us. The atomic mass isn't listed on here, so we can only talk about atomic numbers here. So sodium is, sodium has 11 protons. So we have this nucleus, and there's 11 protons in here. I'm not going to draw them all because I'm trying to draw with my mouse. It doesn't work that great. Sorry, this is what we have to work with today. Poor Mrs. Turner, she has to work without a interactive board every day. That first energy level holds 2, right? And then that next energy level holds 8. Well, this is going to be interesting. Let me do this. So I have 1, 2, 3, 4, 5, 6, 7. I said it will hold 8, but I have to be careful because I have 11 protons. So I have 2. God, did I count wrong? I have 2 plus 8. Nope, I did that right. So I have 8 on here. So then I have another. Oh, I didn't mean to do that, but this is why I'm not an art teacher, right? Nobody wants to see that disaster. So I have 1 valence electron in that outermost energy level. And we said when it forms an ion, it wants to, pick up, it either is going to pick up 7 or lose 1. But anyway, so here's this outer level. So sodium has 11 protons and 11 electrons. If I go to magnesium, there's another, I add a proton, and you know what this does to the nucleus? It makes it even more negative or positively charged because protons are positive. So now that nucleus has a greater positive charge in magnesium than it did with sodium. I do add one more. I add one more electron, but because I'm adding an electron to the same energy level, it really doesn't make the atom bigger. In fact, to the contrary, I have made the nucleus more positively charged, so it pulls those electrons, which are the opposite charge, they're negative, it pulls them closer to this nucleus. So instead of making the atom larger, it actually pulls that energy level in closer. Look at how giant my hands are, right? It actually pulls those electrons in closer to the nucleus. And you guessed it, if I go one more to aluminum, I add another proton and another electron, and it gets even pulled tighter toward that nucleus. So the trend we see going across here, these get smaller and smaller and smaller. Okay, the radius of the atom itself, it gets smaller and smaller and smaller as we go across this group. So in period 3, right here, when I get all the way to argon, this is actually the smallest in size of that whole period. I think it seems, that always seems confusing, like that shouldn't happen, but it does. It gets smaller as you move across, and that's why. So understanding that electron configuration is really key to understanding why that happens. So what happens when I go from argon to potassium? Well, what happens is we add an entirely, so this becomes filled, right? 8 valence electrons with argon. I'm not going to draw them all because nobody wants to see that. But I add a whole new energy level with potassium with 1 electron in. So now it jumped up a size. Okay, it got smaller, 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 and it jumped up. It added a whole new energy level. So potassium is even larger in diameter than sodium. So the trend as we go down, and this does make sense, I think, these, of course, the atomic numbers increase as well, but they actually get larger because we add an energy level with every new period going down. Okay, so remember, and I'm pretty sure we talked about this, when we talk about groups and periods, groups, and again, I apologize, this is me writing with the mouse and not even like the computer mouse, which is worse. Groups 1, 2, 3, 4, 5, 6. I'm not going to write them all. 7, 8, 9, 10, 11, 12. Sorry. I just heard a siren outside. Totally distracted. This is group 13, 14, 15, 16, 17. This is group 18. So please remember that groups go across, periods go down. So period 1, period 2, period 3, 4, 5, 6, 7, right? There's 7 periods. These, remember, fit up into here. I know I talked about this with one of the chemistry groups. I don't know if I talked about both. So again, periods go across, groups go down. The trends that we see, atomic radius decreases as you go from left to right. It increases as you go down a group. And I explain why. It's because those electrons are pulled more tightly toward that now more positively charged nucleus than it was before. Reactivity, how reactive an element is with other elements. Metals, you guys saw this in your lab. Metals, reactivity decreases as you go from left to right, as you move across. Oh, this I'm mirroring, so don't look at that. As you move from, as you go from left to right, it decreases, but as you go down a group in metals, it increases. Non-metals, completely the opposite. As you move from right, excluding those noble gases because they're not reactive. So if you start with the halogens, if I start like with fluorine and go this way in the nonmetals, they decrease as I move closer to the center. Oh, my face is so in the way. I apologize. And then they actually decrease as you move down. So fluorine, the most reactive of the nonmetals. That's the trend. Okay. And then electronegativity. This is how strongly atoms pull electrons toward each other. Okay. We know with metals, they have a really low electronegativity. They give up electrons. They don't gain electrons. So metals have that they have really low electronegativity. The nonmetals, however, they want to grab and fill up this, remember these have one valence electron. They want to fill it up and be like the noble gases, okay? So they have a really strong electronegativity, fluorine being the very, very strongest, which actually makes fluorine very reactive. So these are the general trends then with electronegativity. Decreases as you go down a group, elements that have more electrons as you go down a group, so acquiring more is really not such a big deal. Electronegativity increases as you go from left to right across the period. So when we number these on the periodic table, so just really quick, and I think I talked about this 5th hour, but maybe not 3rd hour. So the groups, the newest way of labeling these is groups 1 through 18. There's a older way that uses that they give these transition metals like Roman numeral. Well, they all are Roman numeral, and then these are like the B group, and the other are the A group. But this is more modern. So 7 periods: 1, 2, 3, 4, 5, 6, 7. 18 groups. Okay, 18 columns. And if I say element in period 6, group 1, we are talking about cesium. If I say element in group, let me see, group 10, period 4, that would be nickel, and so on and so forth. So hope that's helpful. Please answer the Google form when you're done watching this video.